Hello everyone, welcome back to my channel Explain Maths. So in this video, I am going to solve the exercise 1.1 of the chapter Real Numbers. And this topic I have taken from grade 10. So let's begin solving the questions. So first question is express each number as a product of its prime factors. And the first number is 140. So you have to express 140 in terms of their product of their prime factor because 140 is a composite number. Okay, composite number means the number which is having more than two factors, isn't it? So 140 is having so many factors, so it is a composite number. So you have to express this 140 as a product of the prime factors. So for that, I am going to do the prime factorization of 140. So let's begin doing the prime factorization. So the number is 140 and we know that the smallest prime number is 2. So what you can do, you can list prime numbers here 2, 3, 5, 7 and so on and start taking the first prime number and check whether 140 is divisible by 2 or not. So yes, 140 is a even number, so it is divisible by 2. So you have to use here 2. So 2 times 70 will give you 140. Again 70 is a even number, so again it will be divisible by 2. So 2 times 35 is 70. Now 35 won't be divisible by 2. So you have to move to the next prime number, which is 3. And we know that 35 doesn't come in the table of 3 also. So we will move to next prime number, which is 5. So you should know the divisibility rule also. It will make your work easier. So 5 table I know 35 comes. So 5 times 7 will give me 35. And 7 itself is a prime number. So 7 times 1. Once you get a 1, it means your prime factorization is over. So 140 you can write it as 2 into 2 into 5 into 7. And 2 is multiplied by itself 2 times. I can write it as 2 square into 5 into 7. So like this you have to proceed slowly. Now moving to second question. 156. So again you have to do the prime factorization of it. So first you write the number here 156. Okay. Now first of all 156 is an even number. So it is divisible by 2. So 2 times 78 if you do you will get 156. Again 78 is an even number. So again it will go in 2 table. 2 times 39. Now 39 is an odd number. It is not divisible by 3. By 2. So you have to now use the next prime number which is 3. And what is the divisibility rule of 3? You have to add the digit and if sum is a multiple of 3 it is divisible by 3. So if you add the digit 3 and 9, 3 plus 9 is 12 and 12 comes in the table of 3. So it is divisible by 3. So 3 times 13 will give you 39 and 13 itself is a prime number. So 13 times 1. So from here we can write 156 as 2 into 2 into 3 into 13. And 2 into 2 can be written as 2 square into 3 into 13. So this is the like this you have to write 156 as a product of their prime factors. Here 2, 3 and 13 they all are prime numbers. Next is 3825. So 3825 first of all this is a odd number. So it won't come in the table of 2. So now move to the next prime number which is 3 and use the divisibility rule. Once you add the digit 3 plus 8 plus 2 plus 5. So 3 plus 8 is 11, 11 plus 2 13 and 13 plus 5 is 18 and 18 is a multiple of 3. So it is divisible by 3. So 3 times 1275 if you do you will get 3825. Now again this is an odd number. So it is not divisible by 2. So let me check with 3 again. So add the digit 1 plus 2, 3, 3 plus 7, 10, 10 plus 5, 15. So again it is divisible by 3. So 3 times 425. Now let me check again with 3. So 4 plus 2, 6, 6 plus 5, 11. So now it is not divisible by 3. So move to next prime number, which is 5. And we know that 5 table it will go, because divisibility rule of 5 is if one's digit is either 0 or 5, it is divisible by 5. So from here you can write it is 5 times 85. Now again it will go in 5 table, 5 times 17, and after that 17 itself is a prime number, so you can write it as 17 times 1. Okay, so 3825 can be written as 3 into 3 into 5 into 5 into 17, which will give you 3 square into 5 square into 17. So this is the factorization, and I have written 3825 as a product of the prime factors. Now next question, 5005. Okay, so 5005, first of all it is a odd number, so it won't go in the table of 2, right? And 3 table, what is the divisibility rule of 3? You have to add the digit. So if you add 5 plus 0 plus 0 plus 5, you will get 10. So it is not divisible by 3 also. So now move to next prime number, which is 5. So 5,000 times 1001 will give me 5005. Now 1001 is divisible by 7. Okay, so 7 times 143, and then 11 times 13, and then 13 itself is a prime number, isn't it? So like this you have to do it, and then you can write it as 5005 is equal to 5 into 7 into 11 into 13. So this is the way of writing the prime factorization as a product of the prime factors. So it is very important to, you should know the divisibility rule. Here also you must be knowing the divisibility rule of 11 also, isn't it? So use the divisibility rule, it will make your work easier. Now the next one is 7439. So 7429. So 7429, if you see, it is odd numbers, it won't be divisible by 2. Next, if you take 3 also, 7 plus 4 will give you 11, 11 plus 2, 13, 13 plus 9, 22. So it is not divisible. It is not divisible by 5 also. Then 7 also I have checked, it is not divisible. So like this, if you proceed, you will see that it is divisible by 17. And 17 is also a prime number. So 17 table, if you multiply this with 437, you will get 7429. And then 437 is divisible by 19. 19 times 23. And 23 itself is a prime number, so 23 times 1. So 7429 is equal to 17 into 19 into 23. So this was your question number 1. Question number 2. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF equal to product of the two numbers. So you have to find the LCM and HCF of the given number, as well as you have to verify this relationship that LCM into HCF is equal to product of the two numbers. Okay, so let's start finding out the prime factorization of 26 and 91 first. So when you do the prime factorization of 26, you can see here that 26 is a even number. So obviously it will come in the table of 2. So 2 times 13, and then 13 times 1 will give you 20. 13 times 1 is 13. Now next do the prime factorization of 91. So 91, it comes in the table of 7. 7 times 13 will give you 91, and 13 times 1 is 13. Now after doing the prime factorization, let's write it here. So 26 can be written as a product of prime factor as 2 into 13, and 91 is written as 7 into 13. Okay, now after writing this, now you have to find the HCF and LCM of the given number. So let's recall how to find the HCF and LCM after finding the prime factorization. So HCF is the product of the smallest power of each common prime factor. So if you see here, first of all, you have to identify which is the common prime factor. So you can see the common prime factor is 13. And you have to take the smallest power of that. So in both the power is 1. So the smallest power will also be 1. So for HCF, it is 13. Okay, because it has got only one common prime factor, which is 13, and the smallest power is 1. So it is 13. Next, you have to find the LCM. So LCM is the product of the greatest power of each prime factor involved in the numbers. So you have to take each prime factor. So you can see in both the number, the prime factors are 2, 7 and 13, isn't it? So first write that what are the prime factors. So it is 2, 7 and 13. And then what it says, you have to take the greatest power of these prime factors. So greatest power of 2 is 1, greatest power of 7 is also 1, greatest power of 13 is also 1. And you have to multiply it to get the LCM. So now multiply it. So 2 into 7 will give you 14, and 14 into 13, if you do, you will get 182. So from here you got your HCF is 13 and LCM is 182. Now you have to verify this relationship. So first find the product of LCM and HCF. So LCM is 182 and HCF is 13. So you have to multiply it. So 182 into 13, if you do, you will get 2366. Okay. And then the product of 26 and 91, if you multiply 26 and 91, again you are going to get 2366. And from here very clearly you can see the product of LCM and HCF is also 2366, and product of 26 and 91 is also 2366. So from here I can say that LCM into HCF is equal to product of the two numbers, isn't it? So it is verified here. Okay, now moving to the next part of this question. So you have to very clearly see step by step you have to do. First do the prime factorization. Okay, then list it terms of the prime factors. Then find the HCF, then find the LCM. Then find the product of LCM and HCF as well as product of the given number. And then you have to see whether the product of LCM and HCF is equal to product of the two numbers are there or not. Okay, next question is 510 and 92. For this, you have to see the relationship that whether product of LCM and HCF is equal to product of the given numbers or not. So let's begin with the prime factorization. So first I'm going to do the factorization of 510. Now 510 is a even number, so it will come in the table of 2. So I have to write it as 2 times 255. Now, next, if you add the digit 2 plus 5 is 7, 7 plus 5 is 12. So, it will go in the table of 3 also. So, 3 times 85 and then 5 times 17. 17 itself is a prime number. So, 17 times 1. Now, next factorize 92. So, 92 is a even number. So, it will go in the table of 2. So, 2 times 46. Again, it is a even number. So, 2 times 23 and then 23 times 1. So this is the prime factorization of 510 and 92. Now 510 you can write it as 2 into 3 into 5 into 17. Okay. And 92 you can write it as 2 square. 2 you can see here 2 into 2, 2 times. So you can directly write it as 2 square into 23. Now next we have to find the HCF and LCM. So to find HCF, you have to find out the product of the smallest power of each common prime factor. So first of all, you see which is the common prime factor. So common prime factor is 2. And you have to take the smallest power. Smallest power is here 1. Because here power of 2 is 1, here is 2. So the smallest power is 1. So from here I can write my HCF is going to be only 2. Now next we have to find the LCM. So LCM is the product of the greatest power of each prime factor. So what are the prime factors used in both the number? So it is 2, 3, 5, 17 and 23. So first write it. Okay. And you have to find LCM, you have to multiply it, right? So first I am writing it 2 into 3 into 5 into 17 into 23. Now you have to take the greatest power of these prime factors. So greatest power of 2 is 2, which is over here. And the greatest power of 3, 5, 17 and 23 is 1 itself. So you have to leave it like this. Okay. Now if you now next you have to multiply. So 2 square is 4. 4 into 3 is 12. 12 into 5 into 17 into 23 will give you 391. Now 12 into 5 is 60. 60 into 391. And now if you multiply 60 and 391, you are going to get 23,460. So this is the LCM of these given numbers. Now you have to prove the relationship, right? So you have to find the product of LCM and HCF. So it is going to be LCM is 23,460 multiplied by HCF, which is 2. And if you multiply, you will get 46,920. And the product of 510 and 92, if you do, the product of 510 and 92, if you multiply, again you will get 46,920. So from here you can see the product of LCM and HCF is equal to product of 510 and 92. So from here I can say that LCM into HCF equal to product of the two numbers. So hope it is clear to everyone. Okay. Now moving to third question of question number 2. So first factorize 336 and 54. So 336 is a even number. So it will go in the table of 2. So 2 times 168 will give you 336. Again 168 is a even number. So again you have to use 2. So 2 times 84. Again 84 is a even number. So again you have to use 2. 2 times 42. Again 2 table. 21. Then 3 times 7. And then 7 times 1. So this is the prime factorization of 336. Now next number is 54. So 54 if you use here, it will be, first you have to use 2 table because 54 is a even number. 2 times 27. Then 3 times 9, again 3 times 3, and then 3 times 1. Now let's write it as a product of the prime factors. So 336 if you see, 1, 2, 3, 4. 4 times 2 is getting multiplied by itself. So it will be 2 to the power 4 into 3 into 7. And 54 is 2 into 3 cube. Isn't it? Here 3 is multiplied by itself 3 times. Okay, now let's find the HCF. So HCF is what? You have to find the product of the smallest power of each common prime factor. So first find out which is the common prime factor. So common prime factor is 2 and 3. Okay, so first write it here. Common prime factor is 2 and 3. Then take the smallest power. Smallest power of 2 is 1. Smallest power of 3 is also 1, isn't it? If you see here, in here power is 4, here power is 1. So smallest power is 1. Same way for 3, the smallest power is 1 because here the power is 1, here is 3. So smallest power is 1. So HCF is going to be 2 into 3, which will give you 6. Now let's find the LCM. LCM is the product of the greatest power of each prime factor. So first of all, if you see here, in these two numbers, the prime factors which we have used in both the numbers are 2, 3 and 7. So first list out those numbers and it will be the product of those numbers. So 2 into 3 into 7. Now find out the greatest power of 2, which is 4. Greatest power of 3 is cube multiplied by 7 is having greatest power 1 itself. Now multiply. So 2 to the power 4 is 16. 3 cube is 27 into 7. Now, if you multiply all this, you are going to get 3024. Okay. So now we have got HCF, we have got LCM. Now we have to find the product of LCM and HCF. So your LCM is 3024 and HCF is 6. Let's multiply it. If you multiply, you will get 18,144. Now next multiply the numbers 336 and 54. So 336 multiplied by 54 if you do, you are going to get 18,144. And so from here you can see the product of LCM and HCF is equal to product of 336 and 54. So it's verified that product of LCM and HCF is equal to product of the two numbers. Okay, now we'll move to question number 3. Now move to question number 3. So question 3 says that find the LCM and HCF of the following integers by applying the prime factorization method. So you have to find LCM and HCF by doing the prime factorization of each of the number. Okay, so let's start doing the prime factorization. So first is 12. Now 12 is a even number. So we have to use 2 here. So 2 times 6. Again 6 is a even number. So 2 times 3 and then 3 times 1. Next is 15. 15 comes in the table of 3. 3 times 5. 5 times 1. Next is 21. It will be 3 times 7 and then 7 times 1. So my prime factorization is done. Now I have to find LCM and HCF. So for that, first I am going to write these numbers as a product of their prime factor. So 12 I can write as 2 square into 3, isn't it? Because here 2 comes 2 times. Next 15 I can write as 3 into 5. And 21 I can write as 3 into 7. Now I am going to find the LCM. So as per definition, LCM is the product of the greatest power of each prime number. Okay. So here the prime numbers are 2, 3, 5 and 7. So first you write it. It's a product of those numbers. So 2 into 3 into 5 into 7. Now find out the greatest power of this. So greatest power of 2 is 2 and rest all is 1 only. So LCM is 2 square into 3 into 5 into 7 and 2 square is 4, 4 into 3 12, 12 into 5 into 7. 12 fives are 60 and 60 into 7 will give you 420. So this is your LCM. Now HCF is the smallest power of each common product of the smallest power of each common prime factor. So if you can see here, only 3 is common in all the three numbers. Okay, so HCF is going to be 3. So that's all you have to find. You have to find LCM, you have to find HCF. That is done. Now next question. Now next is 17, 23 and 29. By seeing these three numbers, if you notice that all the three numbers are prime numbers, isn't it? And if it is a prime number, then what will happen? They will have only two factors, 1 and the number itself. So in such case, when you find such a situation where all the numbers are prime numbers, the LCM is going to be the product of these numbers. Okay, so LCM is nothing but it is the product of 17, 23 and 29. And if you multiply all the three numbers, you are going to get 11,339 and HCF will be 1. Okay, because 1 is a factor of all the numbers. So the HCF will become 1. I hope this you have studied from grade 4 onwards, isn't it? If to both the numbers are prime numbers, then 1 will be the common factor. Okay, now moving to next question. Question number 3. 8, 9 and 25. You have to find the HCF and LCM using the prime factorization method. So let's start doing the prime factorization. So first I am going to do the prime factorization of 8. So 8 will come in 2 table. 2 times 4 is 8. Again 2 times 2 is 4 and 2 times 1 is 2. Next 9. So 9 comes in 3 table. So 3 times 3 is 9 and again 3 times 1. And then 25, it will come in 5 table. So 5 times 5 is 25 and then 5 times 1. Now I'm going to write this in terms of the product of the prime factor. So for 8, I can write as 2 into 2 into 2, which is 2 cube. 9 is 3 square. And 25 is 5 square. Okay, now let's find the LCM of 8, 9 and 25. So LCM is product of the greatest power of each prime factor used in the number. So in the number 8, 9 and 5, the prime numbers used are 2, 3 and 5. So first write the product of those numbers Then you have to write the highest power of that. So highest power of 2 is 3, 3 is 2 and 5 is 2. And then now multiply it. So 2 cube will give you 8, 3 square is 9 and 5 square is 25. And if you multiply everything, you will get 1800. Okay. Now let's find the HCF. HCF tells that the common prime factor. Okay, the product of the common prime factor. But if you see here 8, 9 and 25, none of the prime factors are common. Okay, if none of them are common, it means HCF is 1 because 1 is the factor of all the numbers. So obviously 1 will be the common factor for all the numbers. So HCF is 1 and LCM is 1800. Okay. Question number 4. Given that HCF of 306 and 657 equal to 9, find the LCM of 306 and 657. So we already know a relation, right? The product of LCM and HCF is equal to product of the given number, right? Product of the two numbers. Now here the two numbers are 306 and 657. HCF is also given as 9 and now you have to find the LCM. So we have to just use that relation and you have to find the LCM. So first of all, we will write what and all are given in the question. So numbers are given as 306 and 657. Then HCF of both the numbers is given as 9. And now we have a relation. HCF, product of HCF and LCM is equal to product of the given two numbers. Now I'm going to substitute the values over here. So HCF of 306 and 657 is given as 9 into LCM. Okay, is equal to product of the two numbers. Now product of the two numbers means you have to multiply those two numbers, 306 and 657. So LCM will be, now I'm going to transpose 9 to the other side. So LCM will be 306 into 657 divided by 9. Now, you know the divisibility of rule of 9. If you add the digit of 3 plus 0 plus 6, you are getting 9. It means 306 is divisible by 9. So 9 times 34 will give you 306. And if you multiply 34 and 657, your answer is going to be 22,338. So from here you can write LCM of 306 and 657 is equal to 22,338. So this is the answer for question number 4. Question number 5. Check whether 6 to the power n can end with the digit 0 for any natural number n. Means you have to find a value for n such that it will give 0 in the ones digit, isn't it? So 6 to the power 1 will 6 only, right? It has 6 in the ones place. If you do 6 square, you will get 36. Again 6 in the ones place. Now 6 cube if you do, it will is 216. Again 6 in the ones place. And if you remember in my first video only I have explained that if the number will end with 0, it means it should have prime factor, one of the prime factor as 5. Isn't it? I have given one example also. So same way here, what I am going to do, I will try to find out the prime factor of 6 and I will see whether 5 is one of the prime factor or not. So if 6 to the power ends with 0, then it must have 5 as a factor. Okay, now let's do the factorization. But 6 to the power n, if you will do, you can write 6 as 2 into 3. 2 and 3 both are prime numbers and 2 into 3 whole to the power n, which can be further written as 2 to the power n into 3 to the power n. If you have remembered the laws of exponent where it says that if power is outside, you can multiply the power in both the numbers. It is 2 to the power n into 3 to the power n. And from here you can see that only 2 and 3 is the only prime factor, isn't it? It doesn't have 5 as a factor. And what we know from fundamental theorem of arithmetic, that the prime factorization of each number is unique. You will not have any other way to do the prime factorization. It means 5 is not a factor. So from here I can say that 6 to the power n never ends with 0. Okay, why? The reason is 5 should be one of the factor, which is not here. Okay, now next move to question number 6. Now question number 6 says that explain why this and this are composite number. Now meaning of composite number is the number which will have more than two factors, isn't it? Composite number will have more than two factors. So we have to just show that these numbers are having more than two factors. So let's take the number one by one. So first it's 7 into 11 into 13 plus 13. Okay, now if you see 7, 11, 13, they all are prime number. But we have to check whether this complete number is a composite number or not. We can see 13 is common, so I can take 13 common outside. So it is left with now 7 into 11 plus 1. And what is 7 into 11? 7 into 11 is 77. 77 plus 1 is 78. Now if you see 13 is a prime number, but what about 78? 78 is not a prime number, right? It's a composite number. And when you do the prime factorization of 78, what you will get? You just check here. 78, if you factorize it, you will get 2 times 39, then 3 times 13, and 13 times 1, isn't it? So you can write 78 as 2 into 3 into 13. It means this will have more than two factors. Can you see it has got so many factors. It has 2, 3, 13, and 1 is a factor of all the numbers. So it has more than two factors. So it is going to be composite number because it has more than two factors. So it is a composite number. Now same way we have to check for other number also. So it is a composite number. Now next number is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Now here also I can see 5 is common. So I am going to take 5 out, take 5 outside. And now here I am left with 7 into 6 into 4 into 3 into 2 into 1 plus 1. And if you multiply 7 into 6 into 4 into 3 into 2, you are going to get 1008 plus 1, which will give you 5 into 1009. Now here 5 is a prime number, 1009 is also a prime number, but 1 is a factor of all the numbers, right? So here it will have factors as 1, 5, 1, 0, 0, 9. Again it has more than two factors. Yes or no? It has more than two factors. So again it is going to be a composite number. Okay, so again it is a composite number. So I have checked that both are composite number and I have given the reason also because for both you will have more than two factors. Now moving to last question of this exercise. Question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field and Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So it is given that their sports field is circular in shape, isn't it? So I have taken here, this is Sonia, this is Ravi. Okay, now both have to take a round of the field. Okay, so Sonia takes 18 minutes. Okay, both are in the same sports field. Sonia takes 18 minutes to drive one round of the field and Ravi takes 12 minutes. It means Ravi is faster, isn't it? If both start at the same point and at the same time and go in the same direction, after how many minutes will they meet together? So if I assume the starting point for Sonia is here, for starting point of Ravi is here, and they are both going in this direction, isn't it? Now it is given that Sonia takes 18 minutes to finish one round, Ravi takes 12 minutes, isn't it? So for first round, Sonia takes 18 minutes and Ravi takes 12 minutes. Fine. Now if Sonia will take the two rounds, then total time taken will be 36 minutes, double of 18. And here also if you see, it will be double of 12, which is 24. Now like this, if you proceed for the third round, C will take 54 minutes and Ravi will take 36 minutes, isn't it? So if you can see here, when they are taking the round, okay, the time which they will take to complete the round is a multiple, isn't it? Can you see here? In such type of question, it is very important to first identify whether you have to find LCM or HCF. So here you can see it is the multiple of the number. And if it is a multiple of number, then very clearly you can understand that you have to find the LCM of 12 and 18. Then only you will see at what time they are going to meet together. So let's find the LCM of 12 and 18. So LCM of 12 and 18. So first find the LCM of factorization of 12. So it will be 2 table 12 will come 2 times 6, 2 times 3, 3 times 1, and 18 if you do 2 times 9, 3 times 3, and 3 times 1. So 12 I can write it as 2 square into 3. Okay. And 18 I can write it as 2 into 3 square. And you have to find the LCM of 12 and 18. Now to find the LCM, what you have to do? You have to take the greatest power of each prime factor. So here the prime factors are 2 and 3, here also 2 and 3. So first write it 2 into 3. Now take the greatest power. So greatest power of 2 is 2 and 3 is 2, isn't it? Here greatest power of 2 is 2, here greatest power of 3 is 2. So it is 4 into 9, which will give you 36 minutes. So from here you can see that they are going to meet again after 36 minutes. Okay, so 36 minutes will be the answer. That after 36 minutes they will meet again at the starting point. So very important, you should first try to find out whether you have to find HCF or LCM. And there is one clue, when something is repeating at a certain interval of time, it is always LCM. Okay. So that's all for today's class. And if you like my video, please subscribe my channel and share with your friend also. That's all for today's class. Thank you.